Let's get started with two definitions. The one is externally owned accounts and the other one is contract accounts. Over here you see kind of where they are located at, and I will tell you what is meant by them. An externally owned account is an account where there's a private key behind. This is the accounts that we use to send funds, initiate transactions, and they live kind of outside of the Ethereum blockchain. They can access the Ethereum blockchain, but they are not deployed code. And contract accounts are those accounts that are inside the Ethereum blockchain. This is where the code is on there, and they don't have a private key to manage those accounts. Code is managing these accounts. You've seen this in our smart contract. We used an externally owned account to deploy our smart contract. We used an externally owned account to send funds to the smart contract, but then we initiated this withdraw money function to actually get the money out again. And there, the smart contract managed itself. It is initiating this transfer function, and this transfer function is using the funds stored on the smart contract to transfer it to another address. Okay, how can you initiate those transactions? Well, what we did, we were initiating a transaction from an externally owned account, an EOA, to a so-called contract account. What you cannot do is have smart contracts or contract accounts initiate transactions themselves. They always have to be kind of triggered from an externally owned account. So this is how that would look like. You can very well trigger a transaction to a smart contract, and the smart contract itself can, during this single one transaction, it's an atomic operation, it cannot in parallel trigger another transaction to somewhere else. It is really during this one transaction, it can contact another smart contract or another contract account and do something there. But it is always rooted, the origin is always from an externally owned account. So this is why you can also have kind of different things where you have one externally owned account interact with one smart contract, that smart contract interacts with another smart contract, or that smart contract sends funds to another address. It doesn't matter as long as there is an externally owned account starting this transaction. Okay, talking about addresses. Remember, on the blockchain, you have a ledger that is shared by all participants, and the information, how much money is owned by which address, is stored on this ledger. It's not stored in your address or on your account or in your wallet. Your wallet stores a private key, and this private key generates a public key, and this public key generates an address. So the blockchain is the database that stores how much is owned by which address. In Solidity, addresses have two very important members. The one is balance, which stores or which has the amount in Wei. Every information is public. You can get the amount in Wei of any address that is stored or that ever sent anything on the Ethereum blockchain. And you can transfer from your smart contract to a specific address a specific amount. Address has also a couple of more low-level calls or low-level members, low-level functions. The one is send. This existed already before transfer, and send returns a Boolean. Now, as I said before, a transaction is an atomic operation. Usually, when you use transfer and there is an exception triggered, and we talk about exceptions in one of the later lectures, there's an exception triggered in a smart contract that you are calling. Then during this transfer, the exception will cascade and the whole transaction will just be canceled. There will no change to any state, nothing. The whole transaction will be canceled and it will be a failed transaction. With send, you can send money to another smart contract or to an externally owned account, or whatever you can do is, if there's an exception happening or if this operation fails, it returns you a Boolean false, and you have to take care yourself of reacting to this. And then there is another function called call value, and you will see this a lot in combination with possible re-entrancy bugs. When you ever heard of the DAO, which was one of the first largest smart contracts that was deployed on the Ethereum blockchain, this had a re-entrancy bug where somebody can call back, but it doesn't fit in this lecture. It would make the lecture far too much to tell you exactly how re-entrancy works. We're doing this in another lecture. Just be careful when you do these low-level calls that you are following the so-called checks, effects, interaction pattern, which we're also going to talk about later. Then one more thing that I want to talk about briefly is the two functions send and transfer. Both only send the so-called gas stipend with, well, sending the ether. That is 2,300 gas. Right now it can change in the future, but right now it's 2,300 gas. And that means you only have this amount of gas for doing any computational things, which is usually enough to emit an event, which we're also going to talk about later. And in general, about this gas stipend, I want to talk about in the lecture where we talk about functions, the fallback function, and the constructor. We used global object, the message object, message value, and message sender. The global objects, there are a couple of more, but the most important one is the message object. This is here to understand and get the information what is happening during this transaction. These properties from the global objects will be set with the properties of the transaction. So in message sender, you will have the address that called this smart contract. In message value, you will have the amount in way that is sent to this smart contract, and so on. There are three very important global properties that I usually work with all the time. That is message sender, that is message value, and that is now, which is the timestamp of the transaction. Be careful with the timestamp. It can be influenced to a certain degree by minors, so don't use it for something like odd or even numbers for random number generation. It's not meant for this. It can be influenced by a certain degree, around plus minus 15 seconds by minors. Okay, let's go to the payable functions. We've seen that you have to mark functions as payable if you want to receive ether. So for example, my function public payable, and just as an FYI, the function is not marked as payable, but you still send ether there, then it will just throw an exception and it will fail. More on payable functions or on functions in general in one of the next lectures. Okay, let's go to the key takeaways. What should be the takeaway from these two lectures? First of all information is public. You are not storing any ethers in your wallet or in your account. You're storing them on your blockchain. That also means that you can get the balance of any address that is interacting with the blockchain, and you can transfer ether. You don't need the permission from someone to that he can receive ether as long as you send it along. And the global objects are quite important. You have to understand at least the message sender and message value object, and those tell you what happens inside a transaction.